Welcome back to a new F# video on inheritance and classes. We looked in the last video on the base class here and the derived class, where we implemented an abstract function in the base class that we provided a default value for, and then we inherited this to give it a different implementation in the derived class, and we could see that these two then gave different results when applied to the same parameters in the end. What I want to do in this video is show you how you can also remove this default implementation. So let's say we have this base class, but we don't necessarily ever want to create anything from this base class. We just want to use it as a blueprint for other methods or for other classes to inherit from. So I would optimally like to remove this guy, but you can see that when I try to do this, I get an error here because it tells me that I have this abstract member, my function, but that it doesn't have an implementation. And there is, in fact, a way for us to provide blueprints like this in classes and then inherit from them without having to provide implementations in the base class. But in order to do that, we need to annotate the base class as an abstract class, meaning that we're not allowed to initialize this class by itself, but rather just inherit from it. The way we would do that is in the following way. So we would provide first these hard brackets, and then also, this diamond kind of shape in the middle. We would anyway write abstract class in here, like that. What that does is it removes this error, but you can see that we get a new error down here. And this is on the initialization of this base class. And what I said before is if you define an abstract class like this, you're not allowed to initialize an instance of that class. So that's why we get an error here. So we're not allowed to initialize this anymore and have to remove the usage of that. And then we also have to remove this printout. But we can still use the derived class, and we can provide an override for this abstract member that we defined in the beginning to give it a proper implementation like this. Now before we got the value of 7 for the derived class, and we're not really changing anything here. So I should be able to rerun my code, execute, and get the same result for my derived class. Now, there are a number of cases where you might want to do something like we just did. So there could be many abstract classes that define, for example, characteristics of different shapes. Let's say that could be one application. You wouldn't want to initialize or instantiate a version of just a shape class, but you would rather instantiate maybe a circle or a rectangle or something, but they still might share common characteristics. And for that kind of application, it's useful to have this abstract class concept. And we can see here now at the bottom that we still get the value 7 once we apply the function of the derived class. So everything works like it did before. It's just that we don't have to provide a default value for the abstract members in the base class.